Hey there, fellow student programmers. Today we're going to explore a classic game that many of you might be familiar with, Snake. But wait, we're not just going to play it. We're going to dive into the code and understand how it works. Now, why is this code useful? Well, besides being a fun and engaging project to work on, understanding how to build a game like Snake can teach you a lot about programming concepts such as game logic, user input handling, collision detection, and even some basic graphics rendering using HTML5 Canvas and JavaScript. So if you're ready to unravel the mysteries behind the Snake game's functionality, now let's dive into the code. Beginning with the HTML portion, we establish the structure of our game interface using a canvas element. This canvas serves as our drawing surface, allowing us to render graphics dynamically using JavaScript. Moving on to the JavaScript section, we initiate by fetching references to the canvas and its context. This context enables us to draw shapes and text on the canvas, crucial for creating the visual elements of our game. Now we define several constants, including grid size, tile count, initial snake position, and initial food position. These constants establish the fundamental parameters of our game grid and starting positions of the snake and food. Subsequently, we declare variables to track the snake's movement direction, the player's score, and the game loop interval. These variables manage the game's state and facilitate the continuous updating of the game elements. Progressing to the draw function, its primary role is to render the game graphics onto the canvas. This function begins by clearing the canvas, ensuring a clean slate for each frame of the game. Then, it proceeds to draw the snake segments onto the canvas, using the specified color and dimensions. Similarly, the food item is drawn onto the canvas, indicating its position to the player. Finally, the draw function displays the player's score on the canvas, providing feedback on their performance. In summary, this function clears the canvas, draws the snake segments, positions the food, and displays the player's score, ensuring an interactive and visually appealing game experience. Transitioning to the update function, we delve into the core game logic. Its purpose is to handle the game logic and update the game state accordingly. Firstly, it calculates the new position of the snake based on its current direction of movement. It checks if the snake has collided with the walls of the game area or with itself, signaling the end of the game if such collisions occur. Additionally, the update function checks if the snake has consumed the food item, incrementing the player's score and generating a new position for the food if this is the case. Overall, the update function ensures the smooth progression of the game by managing the snake's movement, detecting collisions, and updating the score based on player actions. The arrow key event listeners are crucial for enabling player interaction with the game. These event listeners detect when the player presses arrow keys on their keyboard, which in turn dictates the direction in which the snake should move. When the player presses an arrow key, the corresponding event listener triggers, capturing the key press event. For instance, if the player presses the arrow up key, the event listener associated with the arrow up key is activated. Upon detecting a key press event, each event listener evaluates the direction of the snake's current movement and ensures that the snake can only change its direction to a valid one. For instance, if the snake is currently moving upwards, the event listener associated with the arrow up key press will not allow the snake to suddenly reverse its direction and move downwards, as this would result in immediate collision with itself. Instead, the event listener updates the values of the x velocity and y velocity variables based on the direction indicated by the arrow key press. For example, if the arrow up key is pressed, the y velocity is set to -1, indicating an upward movement, while the x velocity remains unchanged. By updating the velocity variables accordingly, the event listeners ensure that the snake continues moving in the desired direction on the next iteration of the game loop. This enables smooth and responsive player control over the snake's movement, enhancing the overall gameplay experience. In summary, the arrow key event listeners play a pivotal role in facilitating player input and controlling the direction of the snake's movement in the Snake game. They ensure that player commands are translated into meaningful actions within the game world, allowing players to navigate the snake and interact with the game environment effectively. Finally, we initialize the game loop using setInterval, a JavaScript function that repeatedly executes our game loop function at specified intervals. This looping mechanism ensures the continuous execution of the game logic, creating a seamless and immersive gaming experience for the player. In essence, this code encapsulates the foundational elements of a classic Snake game, demonstrating key concepts such as canvas manipulation, game state management, user input handling, and dynamic rendering of graphics. In conclusion, understanding and implementing the Snake Game code not only provides an entertaining project for aspiring developers, but also serves as a valuable learning experience with broader applications. This code exemplifies important principles of software development, such as extensibility, reusability, and efficiency, which are essential in building larger-scale applications. The modular structure of the code allows for easy extension and modification, making it adaptable to different game mechanics or additional features. Components such as the game loop, update function, and draw function can be reused or extended in other game projects, promoting code reusability and reducing development time. Furthermore, the code demonstrates efficient use of resources by leveraging JavaScript technologies such as HTML5 canvas for rendering graphics and event listeners for user interaction. By utilizing these technologies, the game achieves smooth performance and responsiveness, even on web browsers with varying capabilities. Incorporating relevant development principles, such as separation of concerns and encapsulation, the code maintains a clear and organized structure, enhancing readability and maintainability. Additionally, the use of modern JavaScript syntax and best practices ensures compatibility with current web development standards, facilitating collaboration and future enhancements. Overall, mastering the Snake Game code not only hones coding skills, but also provides a foundation for building more complex and sophisticated applications. By applying the principles of extensibility, reusability, and efficiency, developers can create robust and scalable software solutions across various domains. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning, so keep coding and keep exploring.